So I'm just curious, so the five-sided star, again, what is that?
So I turn around, so for the five-sided star, I turn a total of 2 times as I'm tracing it.
So
instead of turning 360 degrees, I turn 720 degrees.
Divided by
5, because I turn 5 times.
Interesting. Cool.
So I want to get into and show some of the computer scientists how we're doing more meaty content in here too. So here I want to make a spiral, which is a square and a spiral mixed together, so a square spiral. And I want to walk through how this code works. So you've already seen the repeats, and the new thing here is that I'm using a variable. So students in using Scratch get access to variables. So I'm going to start off and I say I always want to point to the right is 90 degrees. I'm going to give it an initial position. I'm going to put the pen down. I'm going to clear anything else I've drawn. And I'm going to make a new variable, and I'm going to set that variable to length to be 200. Okay? So at first, I'm going to start off walking 200 steps each time. And then I think, well, to draw a spiral or squiral, what do I need to do each time? Well, every time I need to walk forward and I need to turn. Okay? Is the general gist of it. Every time I need to walk forward and I need to turn. I also need to walk forward less each time. Or if I wanted to start from the inside, I need to walk forward more each time. Okay? And so here we're getting to, this is kind of your typical for loop. I have some variable that I'm going to be changing within the loop, and here I'm repeating this 10 times. So it's going to start off going 200 steps. And something I do with the students is to really try and focus them on the individual lines. Eventually they'll be like, oh, spiral, we've done that before, no big deal. But if I change the order of these blocks, that's relevant to what's drawn. Okay? And so I try and focus students on what the individual lines are doing and how each individual line is what leads to the next state or the next state of the environment. So I have them draw tables where they're maintaining each of the variables. And I think the variable that students typically forget to include is what direction they're facing. So in Scratch, the 90 degrees is directly to the right. And then this is 180, this is 0. So in each line, I can say, well, I start off and I've pointed it to the right, and I've set the length to be 200. So I'm going to move the steps, and I'm going to turn right 90 degrees. Bam, new line in my table. So I increase the degrees to 180. I'm going to change the length by -20. So now I'm at 180. And so I think it makes sense with students. A lot of programming is really being capable of paying attention to the effects of individual commands. Individual commands in series and in sequences to figure out the big pattern. Okay, but this ability to trace through the individual lines, so I turn again. Here's an opportunity to talk about mod. So as I go around, here's 0, here's 90, here's 180, here's 270. Is it sensible to call this 0? I could call it 360. Should I call it 0? What makes the most sense? And so just like algebra sometimes I think has a little bit of trouble motivating why you care about coordinates. Why would I care about coordinates? Why do I need to remember which direction negative x is in? And here when we're trying to position our character using x and y coordinates, or here when we're trying to reason about directions or use mods in kind of powerful ways, then it gives it context that's maybe meaningful to the students. Is that a question?
No, it's just I'm sort of tryrying to do.
Yeah,
figure out your direction up there, but
so you've got
180 is.
It's a little weird because we're in this world, in this flat
180
world.
is up.
So 180.
Depending on your frame.
If I'm going to be the character here.
Right.
So to right is this direction.
Right.
So I move 200 steps.
Yeah.
I turn 90 degrees, which is down.
Yeah.
So now I'm at 180. I change my length by 20. I move that 180 steps. I turn right 90 degrees. That points me this way. And then I change my length by 20. And then I move again. Each time I'm going to move and turn right. move and turn right,
Mm-hmm.
move and turn right.
Oh, I see. Okay.
Yes?
Yeah.
And this is a general pattern of setting a variable outside of a repeat and using that variable and modifying that variable inside of a repeat. So in computer science, we call it iteration or for loops or looping. But here they're using those same ideas where they have a variable that they've created, they set it outside the loop and they change it within the loop. This is going to be the foundation of them working with lists, which are like the array equivalent in Scratch, and doing other forms of iteration. Questions?
So they just experienced this at middle school, and that's kind of the level at which they need to know it. And then when they go into like a higher, if they're lucky enough to get good classes in high school or college, they're doing it in a more sophisticated way, and even they're using different terminology.
Yeah.
But whatever they've done, I mean, in other words, the different terminology in college isn't a confusion. They call it something else in Scratch in middle school, and then all of a sudden they're talking about it differently and thinking about it differently, but they make the transition, the experience.
I think that that's a really reasonable question to think about, how well are our students who are learning this content in junior high transferring that to college. So Harvard does something when they start their introductory programming courses where they do a week of Scratch and then they show side by side. Here's the Scratch, here's the C is the programming language they're doing. Scratch, C. Here's how you do it in Scratch, here's how you do it in C. And so some institutions, if they're teaching in Scratch, are really explicit about helping students make those connections. I could see even if you're not explicitly making those connections for students, some of the general techniques of like building a table to keep track of what the variables are at each point. The technique of really like tracing through code and saying, and then this block happens, and then this block happens, and then this block happens. It's hard to think of a measure where you could measure that is being transferred to their new learning environment, but I think that that's one of the most plausible scenarios of how they're really building upon what they've learned in Scratch and other languages. Did that answer your question?
Yep.
Okay. So the big thing from here is use representations to help students focus on individual blocks in the script. So it's a big thing students don't do is focus on individual blocks. They say, oh, that draws the square. But really in computer science, sometimes we're going to solve hard enough problems that we need to know how it draws a square. In what order does it draw a square? Do I want the square to start facing up? Do I want the square to start facing down? Those details are important. The second one is Scratch can help students practice with this kind of algorithmic thinking that's the buzz right now with computational thinking. These algorithms for how to draw a spiral are kind of more general purpose algorithm-y kind of experience. I think that's a little bit less plausible in terms of the transfer case, but I think it's something we're really trying to give our students experience in that, whether it's learning long division or learning the steps for describing a spiral. A beautiful tool in Scratch to help students really focus on this individual step level is a thing called single stepping. So it's a mode, here's just a blown up piece of the user interface, edit, start single stepping. And then what that will do is any block that's being executed will be highlighted in yellow. Okay? And so my general takeaway is use single step mode and encourage students to use single step mode. In the course that I was teaching, I gave bug bursts, which were star bursts, but maybe you give raffle tickets. A lot of schools do that, right? Raffle tickets for some prizes or a good phone call home, etc. And so I gave essentially raffle tickets whenever students did debugging tasks. And so one of the debugging tasks that could earn them one of these little raffle tickets was using single step